So our two most basic factoring techniques are what are called greatest common factors, or finding GCFs, and factor by grouping. Now, for factor by grouping, we don't actually use this a whole lot. This one right here, it's not common, but GCFs are very, very common. And I want to go over how we find a GCF. This should be reviewed, but just to warm you guys up at the start of a polynomial unit, it's a good idea to go over factoring. So I have here a polynomial, this trinomial, 10x cubed plus 6x squared minus 10x, and I want to find a greatest common factor for it. So when you're looking for a greatest common factor, you look in two places, the numbers and the variables. Okay, we want to know what each of these numbers can be divided by, and if any of those divisors are common. So if you look at the numbers here, I see the number 10, and I see the number 6. And this is how I think through the problem. I think, what does 10 factor into? Well, if you remember factor trees, that breaks down into 2 and 5. And it doesn't go any further because 2 and 5 are prime numbers. And the number 6 breaks into 2 and 3. So you see here, we do have a greatest common factor of 2. So that's the numbers taken care of. And then when it comes to the variables, you can think of it the same way. You don't need to. I'll show you in a minute why we don't need to. But if you look at x cubed, that breaks into x, and yeah, we got another x term. X squared breaks into x, and x doesn't break down anywhere, it's just x. So if you look for the greatest common factor here, it's just a single x. Now, the reason you don't need to go through these factor trees for variables is because you simply look at whatever the lowest exponent is for these variables. And right here it's 1, x to the 1th power. So that's our greatest common factor, x. And variables are actually easier to find the greatest common factor for than numbers. So let's take these two bits of information, 2 and the letter x, and put those in here. We're going to say this thing, this expression, equals 2x, that's the greatest common factor, times something else. And what you do at this point is you now take that whole polynomial and divide each one of those terms by the greatest common factor. So 10x cubed divided by 2x plus 6x squared divided by 2x and minus 10x divided by 2x. The reason it's divided by 2x on each of these is this. If you imagine going backwards from what I just wrote here to what we have in that box originally, you know what, here, I want a little more room. If you imagine going backwards in this direction, I would multiply 2x by each of these things. And in this case, 2x would cancel out with the 2x, and you'd have 10x right here. So that's how you could go backwards with multiplication. We're not going to do that. Let's keep on going with the factoring. So I keep that 2x outside, and I say, what is 10x cubed divided by 2x? Well, that's just 5x squared. And 6x squared divided by 2x is just 3x, and 10x divided by 2x is just 5. So here we have a GCF that we've pulled out. That's the greatest common factor. And when you are factoring, there's all sorts of factoring techniques that we'll get into. GCFs are what you always look for first, because if you find one, it makes everything else after that easier. Okay, now, this next example is factor by grouping. Sometimes you will not find a GCF. You won't find the greatest common factor. And if you look at some of these numbers, you'll see why. 15, we've got, let's see, 3 and 5, okay? 6, we've got 3 and 2, and you may be thinking, hey, 3 looks pretty good. 25 factors down into 5 and 5, and at this point, you see we can get no greatest common factor. We don't even need to look at 10, because if you look at 6, that's just 3 and 2, right? Well, there's no 3 and 2 in 25, so there can be no greatest common factor between all of these numbers. And likewise for the x's, we start with x cubed, and we go down all the way to x to the 0th power, right? That's what this guy is over here, 10x to the 0th power. And since there's no x term at the very end of the polynomial, it's just the number 10, there's no common variable factor either. So we have no GCFs that we can use. But we still have to factor this. And what you would do then is a technique called factor by grouping. Here's how it works. You take this polynomial and you simply divide it into two groups. And I always just do it this way. First, I make sure, is the polynomial in standard form? Okay, if it's in standard form, great, we don't need to think about this too much. We just keep on going. what standard form is, that is not a question mark, hold on. What standard form is it just means your exponents go from high to low. Okay, right? 3, 2, 1, 0. So yes, this is in standard form. And once it's in standard form, you do this. You simply put 2 of these. That's, what is it with my 3s today? You put some of these into separate parentheses. And you'll see what we're about to do with this in a second. I took the first half and I put that in a parentheses. And then I'm going to add it to the other half of the polynomial in its own parentheses. 25x plus 10. Okay, so now we have 2 groups. That's why it's called factored by grouping. Here's our first group right here. There's our second group right there. And we're going to factor each of them separately. Now, one important point before I move on. Do you see what I did here with this minus sign? It would be incorrect to simply put parentheses around this and keep a minus sign in between them. That would not be good. Because what it would do is it would say minus 25x minus positive 10. That would be a little different than what we actually have here. See if you can pause the video and convince yourself of why that's not the same as minus 25x plus 10. So you want to make sure that this sign right here is always a positive sign. And you just literally take whatever this thing is and you put it here, and you take whatever this thing is and you put it there. Okay, so those are our 2 groups. And that's really the major error that people make at this point. Now, let's keep on going. We're going to pull a GCF out of each group. And I'll move a little faster here because I'm assuming you know GCFs by now. I see that 3x squared is the GCF for the left. That leaves behind negative 5x and positive 2. And on the right side, let's pull out a factor of 5. So this becomes plus 5 times negative 5x plus 2. Okay? Now here's the key point. Do you see these 2 terms right here? This parentheses and this parentheses. When those are equal, everything's going great. And now here's the step we do. This is going to look a little weird. But you take the coefficients. You put the coefficients into a parentheses. For us, that's going to be 3x squared plus 5. And you take the parentheses that are common. And you put those into their own parentheses. Negative 5x plus 2. And this is our factored form. We have factored this by grouping. And although it didn't look like we had a GCF in the original, we actually had a polynomial greatest common factor. And the greatest common factor of the polynomial was this guy. This negative 5x plus 2 was the GCF. It's hard to see binomial GCFs. So I don't really spend a whole lot of time worrying about it. If you have a polynomial with 4 terms, like we have here, 1, 2, 3, 4, those are typically situations where you can find factoring by grouping to be a useful technique.